In this video, we'll find the electric field at a specific point in space, directly above this negative charge, caused by these two charges. Now, we've done something similarly before in drawing field lines, and if we draw the field lines, we should get a rough idea of the field. So from these field lines, if I'm looking at a position up here, then I would expect in that area the field lines look like they're going sort of down and to the right. I've redrawn the situation here. I've labeled a Q1 on the positive charge and a Q2 on the negative charge. And I've also created a position X up here above the negative charge at the place where we're interested in. So I know if I ignored this minus charge, the field from the plus charge, field lines go out, so the field from Q1 would be up and to the right. So up and to the right is the direction that I would expect the E field from 1. This minus charge, if I ignore the plus one, the minus would have an E field pointing down at that point, pointing in toward the minus charge. So I see I'm going to have to deal with vector addition because one is up and to the right, the other one is straight down. What about the magnitudes? Well, magnitude of field from 1 is KQ1 over R1x squared. What is R1x? That would be the distance from here to here. So I need that distance. And if I look here, I've got a right triangle. So I know that this is 0.04 meters squared plus 0.04 meters squared square root. That should be the length of that side. So I can find that, that's what R1x is. So I'll be able to put that in here. E2, KQ2 over R2x squared, where R2x, that's between 2 and x, that's just 0.04. Now I can find these two. So this is 8.99 times 10 to the 9th Newton meters squared per coulomb squared times Q1, that is plus 3 nanocoulombs, divided by R1x squared. So that's 0.0566 meters squared. How about our units? We have meters squared on the bottom. That cancels a meter squared on the top. I've got a coulomb here and a coulomb squared there. So one of the coulombs goes away. Nano is 10 to the minus 9. 10 to the minus 9 cancels this 10 to the plus 9. That's why we like to use nanocoulombs. Make the math easier. So that this nano goes away now. And so the units we're left with are newtons per coulomb. That is one of two acceptable SI units for the electric field. The other one is volts per meter, but we haven't gotten to volts yet, so that'll be later. 8.42 times 10 to the 3rd newtons per coulomb. And then if we do the same thing here, 8.99 times 10 to the 9th Newton meters squared per coulomb squared times, this time negative 2 times 10 to the minus 9 coulombs over 0.04 meters squared. And again, the units end up as newtons per coulomb. 1.12 times 10 to the 4th newtons per coulomb. Now, to add them together to find the total field, we need to break them up into components. So this we'll call plus x hat plus y hat. E2 is easy, it's one direction. So E2 is 1.12 times 10 to the 4th newtons per coulomb in the minus x hat direction. E1 we have to split up. So E1 is this direction. We just found the magnitude. We want to know the x and y components, and this is 45 degrees. So this one is cosine of 45 degrees times, if this is the magnitude E1, then this is E1 cos 45. This one is E1 sine 45. So we have to take this number, multiply it by sine of 45, and cos of 45, which actually both happen to be the same number, and then put those into the x and y components. So this gives us x and y components. So then the total field, E, in the x direction is, sorry, I wrote this one wrong. This is not x hat, that's y hat. Total field in the x direction is just from E1, this direction here. So 8.42 times 10 to the third times sine of 45. 7.16 times 10 to the third newtons per coulomb in the x direction. EY is, so that's plus, so 7.16 times 10 to the third newtons per coulomb from this one minus this. Minus 1.12 times 10 to the fourth newtons per coulomb. So this is negative 4 times 10 to the third newtons per coulomb. It gives you the x and y components, so we can see that the field goes to the right and down at that point. If you need to get magnitude and direction, then you just use Pythagorean theorem with these two, and you can use the tangent.